Hey everybody, thanks for clicking on this video. Today we're going to be practicing matrix multiplication, which is different than scalar multiplication if you saw the previous video. Here we're actually going to be multiplying one matrix by another matrix. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. Now with matrix multiplication, we have to think about what we did when we did matrix addition and subtraction, where the order of the matrices had to be the same. Now with multiplication, it's a little different. So here we've got this matrix, and this is a 2 by 2 matrix. And we're multiplying this by a 2 by 1 matrix. Now the key thing is that these two have to match. If those two numbers don't match, then we cannot multiply. It is impossible. Now fortunately for us, these two match. And so our answer is going to be of the form of a 2 by 1. It's these two outer numbers. That's what our answer will be. So we have 2 rows and 1 column. So we have one number here and one number here. And so how do we calculate this? Well, this is the first row and the first column. So what we're going to do is we're going to multiply these numbers by these numbers. So in the first matrix, we go across the row. So we're going to go across these, and we're going to go down the column. So we're going to do 2 times 2 plus -5 times -1. And so each time we go across the row and down the column, we multiply those numbers that we get. So we do the same thing for the second row. I go across the row and down the column. So here I have -3 times 2 plus 4 times -1. And so we can simplify those numbers. So we have 4 and 6 makes us 10. -6 and -4 gives us -10. So there is our answer. Again, it's a 2 by 1. Because the two numbers that are on the outside, that tells us what order matrix we will have. So for the second one here, now we're multiplying a matrix by another matrix, but this one has variables. Now the order of the matrices actually is the same as what we had up in number 1. This is a 2 by 2, and this is a 2 by 1. So these two inner numbers, they match. So we're going to end up with another 2 by 1 matrix. So I multiply across the row and down the column. So I have 4 times x plus -3 times y. On the second row, I have -1 times x plus 0 times y. So when I simplify that, I get 4x minus 3y, and I have -x in the second row. So there is our product. Always have to keep checking this, because anytime those two numbers don't match, we can't multiply. So with this one, here we've got a different set where we have a 2 by 2 and a 2 by 2. So the inner two numbers, they match. And so what we're going to end up with here is a 2 by 2. So we're going to have a little bit more to do here. So first row and the second row. So I'm going to multiply across the first row and down the first column. So -3 times 0 plus 2 times -1. Now for this one, I'm still in the first row, so I'm still going to multiply by the first row, but now with the second column, because that's what column I'm in. So I have -3 times 1 plus 2 times -5. So I go across this row and down that column. For this one, I'm now in the second row, but I'm multiplying by the first column. So I multiply these two numbers by these two numbers. So I have negative 6 times 0 plus negative 10 times negative 1. And then I multiply this row by this column to fill in the last one. Negative 6 times 1 plus negative 10 times negative 5. So now when I simplify this, I have 0 and negative 2, negative 3 and negative 10, so negative 13, 0 and positive 10, and negative 6 and positive 50, so that's 44. So here is our resulting 2 by 2 matrix product. All right. For number 4, here we have two matrices of different order. This is a 2 by 2. I have 2 rows, 2 columns. Then I have 2 rows and 3 columns. Now, thankfully, the two inner numbers, they match. But I'm going to end up with a 2 by 3. So 1, 2, 3. 1, 2, 3. So, to fill in the first row, I'm going to multiply these two numbers, the first row, by each of these columns. So 1 times 0 plus 2 times 5. So that's me going across this row and down this column. So next, I do 1 times negative 3 plus 2 times 7. Then I have 1 times 1 plus 2 times negative 6. So now I do the exact same thing, except I multiply using the second row numbers. So I have negative 2 times 0 plus 1 times 5. Then I have negative 2 times negative 3 plus 1 times 7. And then I have negative 2 times 1 plus 1 times negative 6. All right. So in the first row, I have 0 plus 10. That gives us 10. Then I have negative 3 plus 14. That's 11. Then I have 1 plus negative 12. So that's negative 11. Down on the second row, I have 0 plus 5. I have 6 plus 7, 13, and then negative 2 plus negative 6 is negative 8. So there is our matrix product, a 2 by 3 matrix. Now for number 5, what we've got is we have a matrix that is 2 by 1, 2 rows, 1 column. And here I've got 1 row and 2 columns. So the two inner numbers, they match. But what we're going to end up with is a 2 by 2. Now there's only one number in this row, and there's only one number in this column, so I can't go further across this way, and I can't go further down this way. But that's fine, because that's all we need. For our first row, first column, we're just going to multiply 5 times 2. For here, for this first row and the second column, I'm going to multiply 5 times negative 1. Going down to the second row, now we're going to use 6. And so we have 6 times 2, and we have 6 times negative 1. So that means we have 10 and negative 5, and 12 and negative 6. Now what number 6 does is number 6 takes those same two matrices but turns them around. And so here I've got a 1 by 2 and a 2 by 1. Now the inner numbers match, but what we left with is a 1 by 1 matrix, meaning that this matrix is just going to have a single number. And so I multiply across this one row and multiply down this one column. So 2 times 5 plus negative 1 times 6. So I have 10 and negative 6. So that means my matrix here is 4. So this quick example shows you that if you switch up the order, then you're going to get different results when you multiply. Number 7. Now, number 7 is a true-false. So we're saying if matrix A times this gives us that, then that's what matrix A has to be. Well, the easy way to test that is we're going to take this as matrix A and multiply by this second matrix, 1, 2, and see if we get 17, 0. So we write 3, 7, 2, negative 1, times 1, 2. Now this is a 2 by 2, and this is a 2 by 1. So we're going to end up with a 2 by 1 matrix as our answer. So I multiply across the row and down the column. 3 times 1 plus 7 times 2. 2 times 1 plus negative 1 times 2. So let's see. We get 3 plus 14. That gives us 17. And 2 and negative 2 gives us 0. So this is indeed a true statement. Number 8. Number 8 asks, which of these matrix pairs can be multiplied? Now, to help us out, let's write out the orders. Let's see, matrix A is a 2 by 3. Matrix B, 2 by 2. Matrix C is a 3 by 3. Matrix D is a 2 by 3. Matrix E is a 2 by 2. So now we have to pair up each of these and look at to see, are the inner two numbers matching? So A and B, nope. We got 3 and 2, they don't match. What about A and C? Yep, they have a 3, so A and C works. A and D, nope, because 2 by 3 and 2 by 2, those two numbers are the same. Same with A and E, 3 and 2, they don't match. So now we ask about B, C. Those two numbers, they don't match. What about BD? Yep, 2 and 2, they match. And the same for E, 2 by 2, so they match. Matrix C, can we multiply it by D? Nope, because this number here is here. And remember, we have to read matrix multiplication in the order that it's written, because if we flip the order around, as we already saw, it'd be a different result. So I read matrix C like this, 3 by 3, and then matrix D, 2 by 3. So this number has to match that, and it doesn't. Same with C and E. And then finally, D and E, we have 2 by 3 and 2 by 2. Those two numbers don't match. So the only pairs that can be multiplied, AC, BD, and BE. And then finally, here we want to prove that matrix multiplication is not commutative. Well, really all we have to do is refer back to 5 and 6. We already did it. Because all we have to do is show one example where it's not commutative, and that breaks it down. And so here we've got this matrix, and we got this answer. And then we flipped it around, we got a totally different answer. And when you're trying to say that something is commutative, it has to be true all the time. And we just showed, just by one example, that it's not true all the time. And since it's not true all the time, we can't say that it's commutative. So, if you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.